there's an equivalent version of this for offshore, but that would probably be a different animal. I don't think it's possible really to do a gas gathering system course and make it work for both onshore and offshore. There's just some significant differences. So this one's going to be focused on onshore. This is kind of who we're aiming it for. I mean, engineering people in general, you know, production / facilities engineers, senior ops people, people that are working on design, on front end stuff, conceptual design, through detailed design, and with a pretty heavy slant towards operations. Feel free to, if anybody wants to, you know, if there's questions or we want to talk about any issues, let me know. Let's go. I'm going to go through the outline here now. Gas well inflow performance. Now this is kind of, again, this is an area that kind of, is this really a facility subject? It isn't a facility subject, but I'm kind of a fairly firm believer that facilities people, especially more on the production side of things rather than hardcore processing, need to know quite a bit about this. You know, we've certainly in my Amoco VP days, we had significant problems with subsurface and production people knowing subsurface and production, facilities people knowing facilities, but not many people knowing how these things work together. And I think the facilities person that's working on gas gathering systems needs to know about this subject. If anybody wants to talk about that a little bit more, that'll be fine. Simplistically, this the gist of this is going to be to impress upon facilities people the impact of gathering system back pressure on well deliverability. Right? And we've had some horrendous mistakes made by putting in flow lines that are too small and compressors in the wrong places, thinking that we were going to get significant incremental production out of wells and got nothing. Relatively embarrassing if you're the one that's done that, but we should be able to. There's ways to predict that going in. It's not going to be hardcore. If any of you know the term nodal analysis, it's not going to be hardcore nodal analysis, but we're certainly going to be talking about that subject. About nodal analysis, inflow performance, outflow performance curves, etc., and why a facilities person needs to know that stuff. Okay, we're going to look at this is going to be a big issue. This is more production-y, and this would be kind of overview. This would be a review of options, methods for unloading low pressure, low rate gas wells that load up and die and can't flow into the gathering system. This is pretty production oriented, so this would be high level for facilities people. It would be, here are some of the options that are available for liquid removal out of low pressure, low rate gas wells, and we're not trying to turn them into production engineers, but this is just to give them a little bit of an idea of what the options are and why this matters, and how deliquefaction methods kind of are in some ways a complement or an alternative to just simply lowering gathering system pressure, lowering back pressure in wells. So wouldn't be a tremendous amount of detail in that, but it would be enough for the people to know what plunge lift is, what a velocity string is, etc., for keeping wells full. Now, if you work on Trinidad and you've got 300 million a day gas wells that flow at 5,000 psi tubing pressure, that's not really much of an issue for you, but not everybody has that kind of stuff. All right. Gathering system. So again, I think as a facilities guy, I think a lot of our facilities courses don't have enough of the production subsurface information in them. So I've got a little bit of a section in here on the effect of gathering system pressure and its impact on reserves recovery. I mean, simplistically, if you look at a reservoir as a box of gas, your ultimate recovery is a function of the pressure that you walk away from the field and getting pressure down. Compression is going to play a real big role in that. So this is just to impress upon the facilities engineers the impact of compression on ultimate reserves recovery. Fluids composition. This is, I mean, I'm just putting some bullet points up here. We're going to look at what kind of impact does composition have on gathering system design and optimization, operation. We'll look at sweet options, sour options, you know, high CO2 content. A lot of this stuff is going to be driven. A lot of the issues associated with this composition is going to be related to corrosion and material selection, temperature, you know, flow line, flowing temperature of the gas. Do I dehydrate or not? Where do I dehydrate? So there's quite a significant impact on corrosion material selection associated with composition. Rich lean, that's going to be talking about. Are we talking about gas wells that are 95% methane with a half a barrel per million of liquid hydrocarbon associated with them? Or are we talking about real rich gas with hundreds of barrels of liquid associated with them, barrels per million? And the impact that might have on gathering system design and or separation at that, where do you do the separation? Do we run dedicated systems, one for gas, one for liquid? Why, how? There's going to be a lot of issues associated with composition. Produced water, again, produced water is going to have quite a large impact. Where do we, if we produce it, where do we separate it? How fast can we get it out of the system? There's pros and cons to separation at the wellhead as opposed to taking the produced water all the way through to the plant. What are the issues with corrosion material selection? There's issues around hydrate inhibition. And there's obviously issues around multi-phase flow. So we would expect to get into all that stuff. Any questions so far? Let's keep going here. Obviously, hydrates and hydrate prevention are going to be a big issue. There's a number of different options available. We've used most of these in our real field. Sometimes I think we've chosen wrong option at times, well, anyways, I'm not going to tell you personal experience horror stories, but there's some good stuff to talk about in this subject area. Again, I mean, hydrates and hydrate prevention and dehydration. You know, us gas processing people focus on it for, you know, specific reasons. In particular, well, you got to make a sales gas spec, or maybe I'm going through an expander plant that's real cold and I don't want to freeze off. All legitimate issues for us gathering system people. The hydrates are still a big issue, but one of the big issues is still going to be corrosion, the impact of corrosion, and do I really have to put in duplex gathering system, or can I use a carbon steel and inject corrosion inhibitor and hope it works? Yeah, so we're going to be covering that stuff. Some of the different options that we'd be looking at, and covered all these in reasonable amount of detail. You find that a lot of these subjects are interrelated. You know, glycol, there's good arguments for doing glycol dehydration at the well site. It solves a lot of problems fast. It doesn't look so brilliant when I've got 15% H2S in my produced gas. Glycol units operating with that kind of gas are a bit problematic, and we often look for different solutions. So we'll look at that stuff. Multi-phase flow basics. I don't have many bullet points here. You can imagine that gathering system course is going to talk a lot about multi-phase flow. I'm hoping that we're going to use a commercial simulator in the course that we could practice on and do some sensitivities and have a look at. Have to talk to somebody and figure that out, which one we're going to use. I got one in mind. I think that would be a pretty big part of the course. Again, this is not going to be a lot of people initially when we talk about gathering system design automatically think it's all about, you know, multi-phase flow modeling. I think that's a part of it, but I think there's a lot of other stuff that goes into the subject rather than just multi-phase flow modeling. Corrosion material selection. This is going to be a big part of the course. It's not at the top of people's minds maybe in the design stage. or in the first few years of operation, but it gets to the top of your mind when you've got to start getting holes in your system, and it's pretty problematic. A lot of people are finding that out now. They've been finding it out for a long time. Yeah, so there's going to be quite a bit of discussion on this, and the corrosion mechanisms are going to relate pretty strongly to multi-phase flow patterns and compositions. So again, all these things are kind of integrated, and we're going to, I think the right way to be looking at this course is kind of be looking at it from a systems point of view. We can't really take these different key aspects in isolation, independent of the other ones. We got to look at putting them together in the right combinations. So that's going to be a pretty strong theme through the course.
Are you planning on using any corrosion prediction modeling kind of tools with this, along with the multi-phase flow model?
Well, you know, I think we might. I mean, we might use it. Might be whether we're going to use software or whether it's going to be a little bit more simple and show them how to use it, the Ward-Williams monograph, something like that. It might be a little bit more along those lines. You know, we'd probably get into the NACE MRO 175 and its new ISO equivalent and talk about sulfide stress cracking and the new and that documents suggestions as far as material selection. But as far as corrosion prediction, I think we would certainly be looking at mechanisms, and there's probably going to be more emphasis on the CO2 side of things. Certainly talk about the issues around H2S and are you going to get a protective film formed, and what's the impact of salt water and pigging and all that stuff. So, but it won't be hardcore. It won't be like we got hydrochloric. Yeah, it won't be quite as super duper as that kind of stuff, or BP's got Cassandra used to have it, but it'll certainly be talking about concepts. Because I think this is some of these things are courses on their own, essentially. But certainly that's a biggie, and I think a lot of facilities engineers in general don't get much on that. Gathering system layout. This is going to be a little bit more about the configuration of the gathering system. Are we bringing all the wells together into a central point to do some field treating and then having a trunk line going to the plant, or we've got a kind of a herringbone pattern with a bunch of wells tied into a trunk line going to the plant? This has pretty large implications from the standpoint. Well, it's got lots of implications, but from a multi-phase flow point of view, from a piggability point of view, and in particular from what are my options for where can I install compression in the future point of view. So I think what I would plan to do would be to look at different types of configurations and just talk about pros and cons of different ways of laying out a gathering system, which of course has got something to do with, you know, the aerial extent of your reservoir too. Is it long and skinny, or is it depends on the pattern, depends on well spacings, etc., like things like that. A lot of variables. Gathering system layout. This well site field facilities options, I think it's going to be, you know, that's a lot of what we've been talking about up there, is those things. But this section in particular is, now that you've learned about now that they work together, and you can't just, the production guy doesn't have to just assume that the back pressure at the wellhead is fixed and constant and forever, and vice versa from the facilities guy. So this is without being hardcore into integrated modeling details and nodal analysis. We're sure going to try to give them a flavor of it in this course, because you have to. Yeah.
I think it would also be helpful on the corrosion materials side to maybe try to get some shared learnings around the some of the extremes that we're starting to see with very sound CO2.
Real high CO2 and high temperature and high pressure. Yeah, I think.
Try to get to some of the extremes and just cover them.
Yeah.
Really
yeah. No, that's a good point, and That issue comes up, anyways, that issue, we went through a lot of that. I remember BP in Algeria with some of that stuff coming into Insala, real high CO2, real high, high CO2, wet, but expensive to build facilities out in the middle of the sand dunes and stuff like that. Yet the alternative, it was kind of getting beyond 13 chrome stuff, and we were talking expensive materials. They're not good answers, but it's expensive, but still try to find me the best overall option. Yeah, really good point. Anything else on the gathering system? Again, this is going to flesh out more as time goes on, but that's the bones of it. Okay.
All right, well, let's have